Let's take a look at graphing using the TI-84 plus. Let's take a look at our first graph, y is equal to x. Now these graphs are pretty basic, and that's the idea behind them. You probably already know how to graph a lot of them, but the important part here is know how to put them into your calculator so that later on we can graph more complex graphs combining all these basic building blocks together. So even though they seem trivial, plug them in your calculator. Okay, y is equal to x. I'll press my y equals, press my clear to clear wherever's in that line, and then I'll press my x key. The x key is this x, t, theta, little n between alpha and a stat. And then you press graph, and that'll be your graph. Let's say you got an error, or it doesn't look like that. Let's look at the three most common mistakes you run across on the TI-84 plus calculator. And at some point in time during algebra, I'm guessing you'll probably make one of these. I'm going to press my y equals. You can freely go back and forth between y equals and graph. To exit out of anything, you do second mode. So if I wanted to get out of this, I'm in second mode. If I went into something by accident, like I went into this, and I had no clue what it was, second mode takes you out of anything. Okay, so if I go back to y equals, you see across the top it says plot 1, plot 2, and plot 3. Those should be unhighlighted. I'm going to up arrow, put my flashing cursor on plot 1 and press enter one time, and then down arrow. You see plot 1's now highlighted. One of three things will happen if you press graph at this point. This is the first one. You'll get invalid dim. The second thing that'll happen is it'll just actually work. You'll see your graph just like normal. And the third thing is you'll see your graph, but you'll see extra garbage on your screen, like extra boxes. I'll go ahead and press enter on quit. I'll go back to y equals. We don't want any of those highlighted. So I'm going to up arrow, put my flashing cursor on plot 1, press enter one time, and then down arrow. And you see my highlighting's now gone. And if I press graph, then I'll get my basic graph again. Now, oops. Almost forgot the other two things. That's like third or fourth or fifth video I've created today of these calculators. I go back to y equals. You see it's y1 through y7. Down here at y0, sometimes students will put garbage down here. Put a bunch of commas, parentheses, and so forth. Then they press graph, and it gives them syntax error. Now quit's highlighted, so your natural inclination is just go ahead and press enter and quit. Then you go back to y equals, and you think that's weird. And then you see, well, don't get much simpler than that. You press graph, appears to be working now, boom, syntax error. What you should always choose is you should choose go to. So I down arrow to go to and press enter, and that'll go to where your error is. Now whenever I have students come up with this condition here, I ask them if they have kids, and if they tell me they don't have kids, I tell them to quit drinking while they're using their calculator. But one student one semester pointed out to me that she throws her calculator in her backpack without putting a cover on. And then I could understand how you could get garbage like this. But anyway, once you find this, you press clear, clears out that line. And then if you press graph, you'll see it's working then. Now the other thing that happens is occasionally your zooming will get messed up. And to fix that, you press zoom and you choose 6. And that sets it back to your standard viewing window. Which is from -10 on the x to +10 on the x, and -10 to +10 on your y. This zoom 6 is probably the most common one you'll use, if I had to guess, and then the plot 1, plot 2, plot 3 is the second one. Sometimes people, like for example, go in the window here, and they'll screw up these numbers. And then if they press graph, it gives them a window range error. Well, you press enter on quit. Again, if you go to zoom, choose 6, fixes it. These three items I've showed you here should fix 95, 98% of your problems. There'll just be a few that it doesn't fix. Let's look at our next basic building block. Y is equal to x squared. I'm going to press my y equals, press my clear to clear out wherever's not line. I'll choose my x key, and then I'll push the x squared button. And then graph. And that'll give us our graph. Now the next one we'll take a look at is y is equal to x to the third. I don't really care what this graph looks like. I'm demonstrating how do you do it when you have any number in your exponent. Y is equal to x to the fourth, x to the fifth, x to the sixth, x to the 20th, x to the 201st. Now press our y equals, press our clear, we'll do our x key. The caret over here between the divide and the clear, this caret here is how you do a power, how you do the exponent. And then we'll put 3 in and press graph. Let me get that. Our fourth one we'll take a look at is y is equal to x to the 1/2. And I could care less what this graph looks like. I'm demonstrating how do you handle it when you got any fraction up there. In your exponent, that is. And it's even more than that. Anytime you have more than a single number or a single variable in your exponent, the trick is you have to put parentheses around the exponent then. So that's how we're going to plug it in. Come over here, I'll press my y equals, clear. I do my x key, caret, beginning parentheses, and then 1 divided by 2, and then the closing parentheses. TI-83, TI-84 is very forgiving about closing parentheses at the end, but I'll do it for completeness sake. And then I'll press graph, and that'll give us our answer. Our next basic building block is y is equal to square root of x. So I'm going to press my y equals, I press my clear to clear out that line. Not everything's on a button, some items are above a button. You see above the x squared is a square root symbol. So I'll press my second button and then the x squared, and it puts a square root and puts a beginning parentheses for me. Then I'll put the x in, and I'll put a closing parentheses to close that beginning one. And then graph. And gives us that as our graph. You notice it looks exactly the same as the x to the 1/2, and it should because they are the same graph. Cube root of x is one you often see in algebra. So let's take a look at it. Press my y equals, press my clear to clear wherever's in the line. Now, if you don't see it on a button or above a button, for graphing purposes, you'll find it underneath the math button. So I'll press math. And you see the cube root is the fourth one. So to choose it, I can down arrow to the fourth one and press enter on it. Or you can simply just press the number that's in front of it. That's a shortcut. It does the down arrow and enter for you. So I'll choose 4. Puts a cube root, puts a beginning parentheses, I'll put an x, and I'll put a closing parentheses so they match. And then graph. And then that's going to give us this graph right here. Now let's take a look at y is equal to the fourth root of x. I could care less about what this graph looks like. What I'm demonstrating is how do you handle it when you have a number in that slot. When I say any number, I mean 4 and above, because we already handled square root and the third root, cube root, and you can't have a 1 there, or negative, or 0. So 4 or above. This is called your index, number in the slot. So how we do it, press our y equals, press clear. We put our index in first. So I'll put 4 in, then I'll go to math, and we want to choose the fifth one, the one that's the radical with an x for the index. So I choose 5. It does not put the beginning parentheses on there for you, so you need to put the beginning parentheses. And then I'll put the x, and then the close parentheses, and then graph. Looks like the square root, but a little bit closer to the x-axis. Now, if you graph that without the parentheses, you'll get the same graph. And you'll think, well, he's full of it. I didn't have to put parentheses. You don't when it's just a single x. But if you have anything complex in there, then sometimes it won't work. So it's always a good practice on the fourth root or nth root. Whenever you have any number in that slot, always put that beginning parentheses. Let's take a look at the absolute value of x. Press my y equals, press my clear. I go into the math because it's not on a button, it's not above a button. I want to right arrow to num, and ABS is already highlighted. It's our first choice. So I'll press enter on it, and it puts ABS, puts a beginning parentheses for us. So I'll put the x, and then I'll put a closing parentheses, and then graph. And this would be our graph for that. Oops. Okay, let's look at y is equal to x plus 2 over x minus 3. Now I could care less what this graph looks like. I'm demonstrating here how do you graph a fraction on your calculator, or how to do anything with a fraction on your calculator. The guideline is whenever you have more than a single number or single variable on top or bottom, you have to put parentheses on top or bottom. So we have to put parentheses on top and parentheses on the bottom. If I just had a single x up on top, I didn't have to put parentheses on it. It doesn't hurt anything. Other than that, you enter it as you see it. So press y equals, press clear, do a beginning parentheses, x plus 2, closing parentheses, divided by, beginning parentheses, x minus 3, closing parentheses, and then graph. Your graph may look like this. Boy, that's real, real confident. Some of the older TI-84s, it'll put a vertical line right here. It's a flaw with the calculator. The newer TI-84s, you shouldn't see that. You should not see a line. So again, if your TI-84 has a vertical line there, ignore the vertical line. Your graph is the rest of it. Okay. Now we're down to this one. So let's see what in the world this is referring to. That was I haven't been numbering these. That was number 9, I guess. 10. Y is equal to dash square root dash x dash 3. On your calculator, you got 2 dashes. This one down at the bottom, this is your negative. Then the one on the side is your minus. These will cause you headaches in graphing. If your dash is at the very beginning of whatever, it's a negative. So this dash here is at the beginning of our problem. So this will be a negative. This dash here is at the beginning of our square root, so it'll be a negative. If your dash is between 2 items, it's minus. So this dash is between the x and the 3, so this is a minus. Now you might say that this dash is between the square root and the x, but that violates it. If your dash is the very first or whatever, it's a negative. Other than that, we're going to type in as you see it. I'll grab a drink here. Okay, we'll press our y equals, press clear, put in my negative, and then I want square root, so I'll do second x squared, put a negative x, and then minus 3, and I'll put a closing parentheses to close the square root, and then graph. And that'd be our answer. Let's see what happens if I put the wrong dash. Go back to y equals, and the dash is before my x. Instead of a negative, let me put a minus there. And then press graph. You get a syntax error. And you remember what I said earlier, you should always choose go to. So down arrow to go to and press enter on it. It not only goes to the line where there's a problem, it puts it on the exact problem. So you see it's the flashing cursors on that dash, which tells us we put the wrong one. So put the negative. Now you might be looking at that and say, well, if it tells you, if it gives you an error, why are you so concerned about it? You can just fix it and change it to the other dash. Well, let's come over here, and this minus here, let's change this to a negative. And then press graph. You'll see there's no error. We just get the wrong graph. So frustrating, because if this is a problem on a test or a final, you miss that problem completely, and you think you had it perfect. If I go back to y equals, change it back to a minus, then it'll give us what we wanted. Very important you know what dash goes where. Now I'll use that same lecture on every calculator I show. Some calculators don't care. They handle it according to its position in the problem, which is kind of cool. Okay, our last one. We got y is equal to x to the power of x squared minus 3x. Can't remember. Close, I think. Plus square root of x. This is what I'm talking about. We get into a harder problem that's a combination of all our basic building blocks. Remember what I said earlier. If you have more than a single number or single x in your exponent, the trick is to put parentheses around the exponent. So when I plug this in, I want to put parentheses around the exponent. So I'll press my y equals, press my clear, I'll do my x key, caret, that's how you always do a power, put my beginning parentheses for the exponent, and then I got x squared, so I press my x key, then my squared, minus 3x, plus, and then square root of x. So second x squared, and then I'll put an x. Closing parentheses on the square root, closing parentheses on the exponent, and then graph. And we get this, probably. TI-3, TI-84 isn't perfect. Sometimes it gives you parts of the graph are missing. That's as close as we can get without spending a huge amount of effort on it. To find out what the graph really looks like, you'd have to take calculus of some sort. There's a whole chapter in calculus about how to find a true picture of the graph. Now let's say not really into technology. You like plotting points. You know, the best point plotter there was in your class. Everybody else was just happy with 3 points. You had to have 9 or 10. Now this graph right here, we know what that is. That's a parabola. It's our U-shaped graph, like that. Or is it? Maybe graph's coming up like this and looking like this. You just didn't plot enough points to see that. Maybe it's coming up like this and then come back down over here. Coming up like this, come back down over here. Maybe this is coming down at x equals 500. You just needed to plot 500 points and you would have saw it come back down. Graphing by plotting points is the worst way in the world. It only works well if you know what the graph looks like to begin with. Now think what I'm saying. You already know what it looks like. Well, why are you graphing it then? The graphing calculator is a step up. Saves us a lot of time in algebra. It allows us to focus on more of the higher level thinking skills. Still isn't perfect, because if my viewing window, -10 to +10, on the x and y looks like this, that's all I'm going to see. I don't know it's coming back down. Again, calculus is what allows you to see mins and maxes and understand the true picture of the graph. We'll see a technique later on, leading coefficient tests, that will help us just to understand it's coming back down, but it still may not give us a true picture. And that was graphing on TI-84 Plus. Now remember, to exit out of anything, you do second mode.